would a hypothetical alien spacecraft work? Introduction. Humanity has always been fascinated with the possibility of life beyond Earth. We've sent robots and space telescopes to search for signals from other worlds, but so far there's no hard evidence that they exist. In fact, one of the most common questions people ask about alien encounters is how an alien spaceship would work. To answer this question, we need to consider both the physical laws of our planet and the hypothetical physics that alien beings might use to travel through space. What if we could remove the effect of gravity? This is called a reactionless drive, and it provides the fastest ever method of propulsion. It's also useful for space travel. It could be used to carry huge amounts of cargo across the galaxy at speeds faster than light. The idea behind this is that gravity isn't an all-or-nothing force. In fact, it's just a manifestation of acceleration caused by movement through space-time that can be either increased or decreased, depending on how much force you apply to your movement, i.e., if you're moving quickly enough. A theoretical alien spacecraft could have a propulsion system based on anti-gravity technology. It might not be as far off as we think. Anti-gravity is not just a concept of science fiction. Scientists have been fascinated with anti-gravity since the 1800s, and many experiments have been conducted to explore its potential. The earliest known experiment in anti-gravity was proposed by Nikola Tesla in 1894. In his patent application, he described how electricity could be used to create a repulsion force that would lift objects off the ground when they were exposed to high voltages of electricity, 50 kV. Later developments in this area included work done by Otis T. Carr and Thomas Townsend Brown, who both claimed they had developed working prototypes using similar principles as Tesla's design. However, none of these early designs were able to produce large-scale results. It wasn't until NASA announced its research into electromagnetism that modern technology began catching up with our sci-fi fantasies. To get somewhere quickly, you need to create force without burning anything up in the process. When you want to get somewhere quickly, you need to create force without burning anything up in the process. The reason why you can't just burn something up is because it's not efficient. If you're massing 1 kilogram of fuel and then letting it go at full speed, you'll only get about 0.7 times that speed of your spacecraft. You could burn 10 kilograms or 20 kilograms or even 100 kilograms of fuel in order for your spacecraft to reach that same speed, but burning more would make no difference. It's also easier to think about this when we look at an example. Imagine that we have a spaceship with a mass of 1 ton, 1,000 kilograms. If we were traveling along at 0 meters per second, that means we'd need 10 times as much kinetic energy as what was stored inside our ship. Conclusion: hopefully, this article has shown that the idea of anti-gravity propulsion isn't just science fiction. It could be a reality sooner than you think. All we need to do is develop an alternative way of generating thrust and applying it to space travel.